Welcome to The Explainer. I want you to picture something, an old school ironsmith's workshop. You can almost feel the intense heat, right? You hear the constant clang of a hammer, and you see this shower of brilliant sparks flying everywhere. It's in a place just like this, a place of pure transformation, that we're going to uncover some of the most fundamental secrets about the materials that literally build our entire world.
All right, let's jump right in. Our whole journey today kicks off with a trip to a local ironsmith. And it all starts because of a really simple question from someone who's just watching, totally curious. And you'll see, this one question is going to unlock how all these ordinary objects we see every day, like cooking pans and farming tools, are actually hiding some pretty extraordinary secrets. So, the smith, he pulls this glowing red-hot block of iron straight from the furnace and just starts hammering away at it. An onlooker, completely amazed, just has to ask, "Why are you beating it?" And believe it or not, that one simple question, well, that's the spark that ignites our whole investigation into the hidden world of materials. That hammering action reveals the very first of what I like to call a metal's superpowers. We're about to uncover these incredible hidden properties that make these materials so uniquely useful to us. And here it is, the big aha moment. The realization that all that brute force from the hammer, it isn't actually destroying the iron. Nope, it's reshaping it. This is our very first major clue in this little scientific mystery. Some materials can be hammered totally flat without breaking apart. And you know what? This property isn't just stuck in the smith's workshop, it is everywhere. I mean, think about that super thin, shimmering silver foil they put on fancy sweets. Or just the regular old aluminum foil you have in your kitchen, right? The stuff you wrap leftovers in. Both of those things exist because of this exact same principle. So this first superpower, it has a scientific name. It's called malleability. It's just a way of saying it's a material's ability to be beaten into thin sheets. Now, gold and silver, they're the champions of malleability, the best of the best. But like we saw with the iron, it's a key feature for most metals. On the flip side, you've got materials like coal that just shatter when you hit them. We call those brittle. Okay, next up is a superpower that's kind of like a close cousin to malleability. It's called ductility. This is the amazing ability of a material to be stretched or drawn out into a really thin wire. It's the whole reason we have things like copper electrical wires or the metal strings on a guitar. I mean, you definitely can't make a wire out of a piece of coal, right? And get this property can be taken to some absolutely incredible extremes. Just to put it into perspective for you, take just 1 single gram of gold. That's about the weight of a paperclip. You can draw that tiny amount into a wire that is 2 kilometers long. No joke. That is just astonishing when you think about it. All right, on to our third superpower. Have you ever dropped a metal spoon on the tile floor? You know, that distinct ring it makes? Well, that property has a name: sonority. Metals are sonorous, meaning they produce a ringing sound. It's exactly why school bells are made of metal, totally different from the dull thud you'd get if you dropped a piece of wood. So we've established that metals can be reshaped and they make a ringing sound, but their powers go way deeper than that. They go into the invisible world of energy. So let's take a look at how they've basically mastered the flow of heat and electricity. So check this out. Here's a super simple experiment you can actually try at home to see this in action for yourself. All you need to do is fill a glass with some hot water. Then stick a metal spoon and a wooden spoon in there. Just let them sit for a few minutes. Now, what do you think is going to happen when you touch the top end of each spoon?
Yeah, the result is pretty much immediate. The metal spoon, it gets hot. That's because heat travels super easily right up through it. It's what we call a good conductor of heat. But the wooden spoon stays cool because wood is a poor conductor. And that right there is the exact reason why our cooking pots are made of metal, but the handles are almost always made of wood or plastic. It just makes sense.
And it's not just heat. This very same principle applies to electricity. Materials that let electricity flow through them easily are called conductors. Metals like copper and aluminum are fantastic conductors, which is, of course, why all our electrical wiring is made from them. And it's also why an electrician's screwdriver has a thick plastic handle. That plastic acts as an insulator to protect them from a nasty electric shock. You know, for all their amazing strengths, metals have a huge weakness, a vulnerability. It's like they have this one great enemy that is relentlessly attacking them. And you've all seen it, that flaky, reddish-brown stuff that shows up on old iron gates or tools. We are talking, of course, about rust. So what exactly causes it? To figure this out, we can look at a classic, simple experiment. Picture this. 3 bottles, and each one has an iron nail inside. The first bottle, bottle A, just has an iron nail and some dry air. Bottle B has a nail and water, but it's sealed so no air can get in. And then there's bottle C, which has the nail with both water and air. So, what's your prediction? Which nail's gonna rust? And when you look at the results, the answer is crystal clear. The nail in bottle A with just dry air, no rust. The nail in bottle B with just water, nothing. But the nail in bottle C, the one with both air and water, that one is covered in rust. And this reveals the big secret. It's not air alone, and it's not water alone. For rust to form, iron needs both of them, together at the same time. This whole process of metal breaking down is called corrosion. And for iron specifically, that's what we call rusting. And this isn't just a small problem, it's a massive one. It costs enormous amounts of money every single year to repair or replace all the metal structures around the world that get damaged by it. But check this out. There are some stunning exceptions. Take the famous Iron Pillar of Delhi. This thing weighs over 6,000 kilograms. It has been standing out in the open, exposed to all the elements for more than 1,600 years, and it has barely rusted at all. It's just an absolutely incredible testament to the advanced skills of ancient Indian metallurgists. So far, we've been talking all about metals. But what about, well, everything else? It's time to flip the script and look at the other side of this story, the non-metals. Now, they might not be shiny or strong in that classic metal way, but trust me, they are absolutely essential. So let's just quickly break down the key differences here. On one hand, you've got metals. Generally speaking, they're lustrous, shiny, they're malleable and ductile, and they're great conductors. Their oxides also tend to be basic. Then you have the nonmetals. They're pretty much the opposite. Usually they're dull, they're brittle, and they're poor conductors. And their oxides are acidic. It's a really clear and useful way to think about them. But seriously, don't underestimate these guys. Here's exactly why we need nonmetals. The oxygen we need to breathe to survive, that's a nonmetal. Carbon, which is the fundamental building block of all life on this planet, also a nonmetal. Nitrogen is absolutely essential for the fertilizers that help grow our food. Chlorine purifies our drinking water, and we even use iodine as an antiseptic on cuts. The bottom line is we literally cannot live without them. Okay, let's bring this all home. Once you really get a grip on the properties of both metals and nonmetals, you start to see it everywhere. You see how these two groups of materials have quite literally built human civilization, from the very beginning of our history right up to our latest inventions. I mean, just think about it for a second. The incredible strength and malleability of iron, that gave us plows, which completely revolutionized agriculture. The amazing conductivity of copper and other metals, that's what powers our entire world. And the really unique properties of special metals and nonmetals, all working together, that's what makes the smartphone in your hand actually work. These materials are truly the foundation of our society. So we've gone on this incredible journey from an ancient ironsmith's forge all the way to the phone in your pocket, just by understanding the basics of metals and nonmetals. We saw how metals gave us the tools and technology that built our world, which brings us to a final, really big question. What new materials, with what new kinds of superpowers, are going to define our future?